Hi, and welcome to this video on Tic-Tac-Toe in 90% pure AL. Hey, I'm Eric, and back with another gaming video. In the last video about blob storage, we had something on the screen that might have looked like a Tic-Tac-Toe game, and I asked you if you wanted to see a Tic-Tac-Toe game. You did. And I also wanted to do something special for the fact that the channel has reached 1,000 subscribers. That's cool. Thank you to every single one of you. That makes my day. But then I got to think about what should be the criteria, because Tic-Tac-Toe has been done also in AL before. So it has to be something different, something special. And I kind of laid out two rules for this. The first one is that don't cheat, meaning that I could just do this in JavaScript and we'll be done in an hour. But that has been done before, also in AL, so no fun with that. So it has to be done in as pure AL as we possibly can. The other criteria is that I would love to, for the celebratory kind of a aspect, I would love to use as many tricks from the channel as possible. So I sat down the other night and started programming, and let me show you what I came up with. Let's see what we got here. Here is Visual Studio Code. And the first thing I thought about was perhaps to fulfill my first criteria, that this should really be as pure AL as possible. It was the visual layout. So how do we actually show a board? And let me find this one in the UI folder, the Tic-Tac-Toe board. So here's what I did. I have a page, and let's look at the layout. The content area, I have a group in it that's called Game 1, another group called Game 2, and another group called Game 3. In these groups, we have a grid with a grid layout of columns, and then we have 3 fields, and the same thing in Game 2, 3 fields, and the same thing in Game 3. So we have 3 rows with 3 fields each. So that's kind of a 3x3 grid, which is what we need for Tic-Tac-Toe. As you can see, the fields I have created here are just called B1, B2, B3, 4, 5, 6, 7, 8, 9. So just 9 fields. So what are these fields? So that's the next thing. In order to, because we cannot just have a text field, and that'll also be kind of difficult to control. So I wanted it to be bitmaps. I wanted it to look nice. So in order to show a bitmap, the best way, you have to have a blob field, and since you cannot create a blob variable, it has to be a table. So behind this, you can see that the source table for this is called TTT board. So let's find that table. So here's TTT board, and first trick from not a trick, but stuff that we have talked about here on the channel is the new table type temporary, because I have no intent of the game board ever being stored in the database. So the game board record is table type temporary. And you can see it has 9 fields, all blobs, and then a primary key field. So very, very simple, but exactly what I need, because I need those 9 bitmaps. Excellent. But the problem with a bitmap is that you can't click on it. And this is where the first percent of being 100% AL thing kind of goes away, because I need to capture if the user is clicking on a bitmap. And how can you do that? Well, we can do that in JavaScript. So let's open the JavaScript folder here and see what I did. What I did was I created let me show you here, the user control. I have an event called control clicked. If I look at my startup JSON script, sorry, not that one. Let's see. I think I add. There we go. I also created a procedure called attach click tracker. So let's find script.json instead. And we can see here the attach click tracker. If you remember I guess that was the first thing, that was the barcode video. Or videos, so the barcode video, barcode reader video, and the point of sale video, where we talked about escaping out of the iframe and attaching the event listener, an event listener for the keyboard on the parent, meaning the Business Central page. In this case, we're not using the key down event, we're using the mouse down. So we really want to know when the mouse has been clicked. And when the mouse has been clicked, we're calling the key listen function, which is right here. The key listen function will give you a lot of data. One of the cool things is that there's a data stream called path, which is an array, meaning that that's all the layers in the DOM. So you click on something, that something is part of something else, that something is part of something else, and so on and so on. Finally, it's part of the body, and then it's part of the HTML page. And one thing that we learned in the JavaScript workbench video was that we could find the name of the control. So at some level there was a div with a attribute called control name. So what this function will do is that it will loop through the different layers, and if a layer has an attribute with a control name, then we'll call the control clicked and pass the control name as the parameter. So 10 lines of JavaScript. So what happens is that if we go back and look at our board here, you see the B1, the B2, and so on. That's what's in control name. So now we can, if a user is clicking anywhere on a control, we will actually get an event saying back, the user has clicked on this, do something, which is exactly what we want, because we want the user to click in the grid. While we're out here in the JavaScript, you can see that I also created, let's go back to user control for a second. I created you see, actually still have the function render, because I just copy. I always start with the dynamic HTML from that video, set up so I have, you know, the bare minimum of a controller in, and then I work out from that. So what I did was I created a timer. So this is the other percentage taking away from the pure AL experience, because we don't have the concept of a timer in pure AL. We used to have back in the classic client, and then we had the ping pong control, so on. But now we can just do this in pure JavaScript. And the way the timer works is that we have a start timer, and uses the window.set interval, and you pass a function and an interval in milliseconds. So we set this to 1,000, then every 1 second this function is called until we use the stop timer to clear the interval. So we have a global JavaScript variable called timer handle that keeps track of the timer, so we know which timer to stop again. And we use this, I use this in the game because you really want a gaming feeling, so that when the user clicks, then the computer will think and then makes its move. And it's not that CPU intensive to figure out where to put the next piece in a tic-tac-toe. So instead of it being instantaneously, you want it really to feel like there is reaction time. So that's the other part of the JavaScript thing. Then let's close this off. Then let's get into initializing the game. So all the game logic I have put in a code unit called a game engine. So we have a game engine code unit, and I will start by locating the function here called, see if we can make this bigger, called new game and clear board, and it gets a variable board. So one thing that's important to know about the temporary table type is it's not session-based temporary. It's per object-based, per variable-based temporary, just as if you had added temporary to source table temporary or temporary on a variable. So you still need to pass that temporary around if you need to use it elsewhere. And so that's why it's always passed into this one. What we can see here is that we go through 1 to 9, so the 9 positions in the grid, and I have created a global variable in this code unit called current board, which is an array of 9 of enum position type, and enum position type is just down here right now. And we have 3 options for any field. Either it's blank, or it's an X, or it's an O. So we set all 9 positions to be blank, and then we call a function called set bitmap on position. Pass the board, and the one is actually we could actually improve this just a bit. Instead of the 1 here, then let's do this. And then we need a 2 integer on. That's interesting. We're not allowed to do that. You know, guys, now I'm sidetracking myself. We'll get back to this if we got time. I'll just leave the 1 here for now. The set bitmap on position. Let's take a look at that one. So the rest of this function is just stating that we have a global saying the game is running, and the human player is is the X, and the computer player is the O. But let's take a look at set bitmap on position. So this is, as you can see here, there's some weird stuff going on. So in the video about base 64, we play around with putting an image into a base 64 string and back and forth. And in this case, I need the game to have the resources. And the resources in this case are a blank image, an image with the X, and an image with the O. And in AL, it's kind of strange, but you can't really have resources the same way as you can have in other programming environments. But using the base 64 thing, it's actually pretty easy. So I created some bitmaps. And the actual bitmaps are actually sitting here, but they don't do anything. Here's an O, here's an X, and here's a blank. So this is blank XO here, and what we do is that we get a record ref from the board. With the board is the record with the 9. Then we have a temp blob. Remember that from the temp blob video. So we create an outstream. Then we use the from base 64 from the base 64 convert code unit to take one of the 3, depending on what image type you want, and put into the temp blob. So now we have converted the base 64 string into an image, putting it into the temp blob. Then we use a special function on temp blob code unit called toRecordRef to take the image in the temp blob and put into the field number of the position. Meaning, because what I did, it was a small hack, but if you noticed on the table, field 1 is B1, field 2 is B2, 3, and so on. So I put the primary key down here at number 10. So field number happens to match the position in the grid, meaning that I can just say that that field in the record ref, let's see if we can make this so you can see the tooltip. The field number is simply the same as the position number. And as with record ref, then we are done working with that, you need to set back to the record. So with this function, we could put a bitmap in any bitmap in any of the 9 positions on demand. Of course, we could imagine caching these things, but computers are fast enough that this, even though we're doing this for everything, is still lightning fast. So that's how we put the bitmaps on. So now we are kind of ready to start the game. So we have drawn the map. It's all blank. We know how to capture something. So let's go back and take a look at the board page. See what else we have here. So after this, so now we have the user control, and that's just a single pixel, right? And on the control ready, we call the attach click tracker. The attach click tracker, if you're clicking on a control, you'll get the control clicked back. If last click, so let's go in here. Say we can see that this calls engine clicked. Engine.user clicked with the board and the control number that was clicked sorry, the control ID, I guess is the right control name. And if the user's actually clicked in, and if this returns that you actually clicked in one of the 9 and not somewhere else, then we'll start a timer for half a second. And we can see that the timer down here is, so this is half a second later. We'll figure out that if you clicked on something, then we set last click back to 0. So the last click is 0 here is to prevent the users clicking twice before the half second has gone. And then it will check to see if there's room left in the board to put something. If not, then you get a cheesy movie reference. Otherwise, we'll call the engine.playComputer. So let's take a look at user clicked. User clicked. So user clicked somewhere. If not game running, then exit. And right now, we just simply evaluate the second character. If that's a number, then we figure out whether the board is blank. So you can only click on something that's blank. If you clicked on something that's blank, then we will set the bitmap on position to, right now this is actually, there should be a human player here. We'll just ignore the warning for now. So we set the bitmap on that position to human player, and we update the current board array to be human player, and then we check, have a function called check winning. And maybe we should look at that one, because there's something also quite interesting in that one. So let's take a quick look into that one. So check winning takes a parameter for the board, of course, then it takes a position and a type. So meaning that, is it X's or O's? And then we see it has a variable called options, and that's a dictionary of integer, comma integer. So remember when did we play with dictionary? We played with dictionaries in the video about using those instead of a temporary table to store certain things. So a dictionary is a simple lookup where you have a key and a value. And in this case, both the key and the value are ints. And the idea behind this, so we have a function called get options for grid position, passes the position of the grid and this dictionary. So let's take a look at this one. Oh, it's right here. So the idea behind this function is that for every grid position, we have a let me see if I can illustrate this somehow. So let me just hang on, stay tuned. I'll just grab my pen and then very quickly draw the most beautiful tic-tac-toe board you have ever seen, apart from the one we're going to see in a bit when I finally run the game. So, this is 1, 2, 3. So the idea is that when we're asking for positions of 1, meaning that if we put something here, what are the set of pairs that goes together with this one? In this case, 1, 2, 3. So that's an option. So I could do x, x, x. That would be an option. So that's 2 and 3. Then there's also 1, 4, and 7. So that's the next one. And then there's 1, 5, and 9. Same thing if we ask this about 2, then you know it's 2, 5, and 8. Wow. See if I can. Or it's 2, 1, and 3. So this function will give you the set of pairs to check with for each position. And of course, the 5 in the middle is the one with most combination allowed to it, and the even positions, again, the even positions, so 2, 4, 6, and 8 only have 2 options, and the corner have 3 options. So that's what the get options for grid position will do. Then we will loop through for each position 2 in option.key. So we will now get a list. So keys returns a list of ints. So these are all the keys. So if the key position is the type that I'm testing for, and the value of the, so if the position of the value of the key is also this type, then I'll return true, otherwise false. Meaning that we can check by placing something in here, is any of the winning combination fulfilled? And if that's the case, you will get a message you win and the game is no longer running. So that was user clicked. That will then wait the 500 milliseconds and the timer will tick, and eventually will activate the play computer function. And actually I did this one with my kids. So we played around with this. So the idea here was that when it's time for the computer to make a move, we could take one of the, you know, off Wikipedia and make sure that every game ends in a tie. But what's the fun in that? So what we did was try to come up with our own little engine here. So we loop through all the grids. Then we realized that the only places where we could put an O, in this case, as the computer, would be somewhere that's blank. So when we find something that's blank, then we'll get the list of options. Run through the options again here. And then what we want to do is that we want to calculate a value. So for each blank, we want to calculate a score. And at the end, let's place the O in the position with the highest score. So what can influence the score? Actually, the first thing we did before we even considered was that the odd positions. If we go back to this one, so the odd positions, meaning this one is odd 1, 3, 5, 7, 9. Wow, that's some beautiful X's, Eric. They seem to have a higher value than the even positions. So we did a position mod 2, so all the odd ones will start by a score of 1, all the even ones will start by a score of 0. Then we started saying that if either the position, so we have two, we have either the position, that comes out of the key, or we have the option the value of the position from the option. If those are different from a human player, then we will give it a score, meaning that if either it's blank or myself in some of the corresponding grid positions, then that's a score of 1. If we see, and this is great, this alone will make the computer think, try to put the place where it has the highest probability of making something. We quickly figure out that there were too many ways of cheating with that. So we told that if there were something from the human player in the same thing, then that was probably also actually more valuable. So defensive kind of score, saying, okay, we probably need to stop that human from playing. Then on top of that, we added that if we found a blank and the human had the 2 others, then that was probably more important than anything else, almost. So we gave that a score of 10. And then the last one, we said, but if we have the 2 others, then we only need to put something here to win. So we gave that a score of 100. And then we added some more values in some cases and stored the whole thing in what is known in another dictionary called moves, which holds for each grid position holds the score. Now we have that list, so we run through that and find if we have a move for a position. And then we find the best value, the highest score. And in case of a tie, we use a simple random. So sometimes we'll use one, sometimes we'll use the other. It's just 2 or 3 fields that have the same score. And we also create a nice little string for debugging, so we can see the different scores. And at the end, we update the board with the set bitmap on position. And we're gonna check if we won, because that would be nice. So with that, I think, and I can see the time is flying. So let's actually see the room left function we mentioned. So this one will check if there's any blanks left. So let's compile this thing and deploy, see how it goes. I will log in. And here's the Tic-Tac-Toe board. So there's we can clearly see that one. So let's place in the middle. So I place my X. I just clicked. I got an O there. Let's go here. Oh no, he's figured out what I wanted to do. How about here? And now I need to stop him. Oh, he tricked me. Damn. So computer wins. I can do a new game, and so this is how my daughter has been saying. Okay, I go here, I go here, I go here, and I won. And I thought, okay, I told my daughter we need to stop that, and she, no, it's good. There's a way in a game to win it. But if we do anything else, if I paid attention, we would end up in the classic tie. The JavaScript thing with clicking on this works surprisingly well. And I think the mission, my two my two mission goals were to make this as much AL as I possibly can was achieved. So only two small instances where I need to capture the click and do the timer, so we have this nice flow where you click, something happened, then the computer wins. I'm clearly bad at this, by the way. I think that's an acceptable use of JavaScript, but the rest is just pure AL. And the grid is kind of strange, because if you go into design and you say, okay, I want to run this on a tablet, that works fine. But the grid almost work in landscape on a phone, but not really. So this is not a mobile game. Anyway, the source code is up on GitHub. I was thinking about creating a multi-user one, but I kind of, with the kids, got into the whole let's figure out how the computer should move instead. So I think I will leave it there, but you guys are welcome to take the source code and make something else of it. And if you haven't subscribed, please do. There's still room for more. And there are lots of more videos coming up soon. So until next time, have a wonderful day.